Okay.
All right.
Just hold it open somewhere. Okay. All right. Are you in the quiz?
I am, yep. I'm just working on downloading the SPSS files.
Okay. I'll open that as well.
Which one do we use first?
Man, we don't have it. We don't have 2 freebie questions this time.
What do you mean?
Like did you do the preparation assignment questions, or do we have
Oh,
those?
you don't have that?
I don't know.
Got it on mine. I've got number 1, I completed the preparation. Number 2, participated in the meeting.
All right. Well,
That's really weird that yours is different.
it would be really awkward if I opened up the wrong quiz.
Very funny. Lesson 13 group meeting quiz.
Okay, well, I think I opened up the homework quiz. That makes sense.
Ah,
Just 1 second.
no worries. My SPS is super slow.
Okay. My wife always laughs at me because I'm like always doing embarrassing things.
Like what?
Like, for example, the other day at physical therapy, there was this girl that came in that she had a wound that we were working on her foot. Because there's a wound clinic in the physical therapy clinic as well.
Okay.
And like she looked kind of stressed. And so like I was trying to like lighten the mood. So I'm like, in the other room, in the room next door, they do amputations. So like, if it gets too bad, like they'll just take your leg, you know, kind of like joke around. But I didn't know that she didn't think I was joking.
No.
And so like, the physical therapist came in to like work on her foot, and she pulled out a scalpel and was gonna like start working on the wound, and the girl totally passed out. Like she like thought the physical therapist was gonna like do an amputation or something,
oh my
but
gosh.
after I went and apologized. But yeah, I do things like that. I opened up the wrong quiz.
That's got to be the greatest story I've heard today.
Okay.
Oh man. I guess some people just can't tell when others are joking.
Yeah, I guess so. Yeah, I guess not. So, I guess I'm not that good of a jokester, I guess.
I don't know. That's just
Yeah. I'm on number 3 now, so.
Oh, perfect.
I'm ready.
All right. So I can go ahead and read this one off. What requirements must be checked when conducting a hypothesis test comparing 2 meanings with independent samples? Mark all that apply.
Well, it needs to be a simple random sample, right, from each population.
It needs it to be also normally distributed.
Yeah.
I don't think these are not correct answer, is it?
Yeah, I don't think so.
Okay.
So it could just be those 2, right?
Could be. I don't remember him saying another one in the video. I mean, I could kind of understand D, but I just don't remember him talking about that at all.
Yeah, I don't think so, because one of the examples from the individual preparation, like the sample sizes were different.
That's a good point, yeah. Good point. Yep, so probably just A and B then.
All right. The test statistic for a hypothesis test comparing two means with independent samples is a...
It's probably not the F statistic.
Yeah.
That's the t-score, right?
Yeah, I think so.
Yeah, pretty much the t-score for all of them except the one that's the z-score.
Yeah, I think so. I think that what I've noticed.
Yeah. So two samples are independent if I think this one is B, right?
Yeah.
Okay.
Because A would be dependent, right?
Mm-hmm. Yep. One determines the other.
Yeah. All right, for the next 6 questions, use the data file dentist office bills. This data represents a simple random sample of dental bills at a dentist office in Idaho Falls and a dentist office in Rexburg. Let population 1 be the mean bill at the Idaho Falls office, and let population 2 be the mean bill at the Rexburg office. Perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office, which means we have the null hypothesis. Population 1 equaling population 2, and the alternative hypothesis, population 1 being less than population 2. Use the level of significance 0.10.
Awesome. Okay. Oh, I have to remember how to do this. It's wait, what was that?
I was just saying it's a little bit of a process, but what were you saying?
You go to automatic recode, right, when you're trying to set up the...
Yeah.
Okay. I assume we're doing city here.
My SPSS is taking forever to load now.
Oh, no worries.
Yeah, I need to refresh my memory by looking at the prep assignment.
Yeah.
I'm a little rusty.
I think I got it, but I'm not very confident, so... See what yours ends up being after you put it.
Find it somewhere. So for step 1, the automatic recode thing, or did you?
Yeah, I did automatic recode.
Okay. Okay. So the variable is the dentist bill, right? So you throw that in there.
After this isn't part of the recode part, right?
See,
Or are you doing the recode right now?
I am doing the recode. Yeah.
Okay. So what I did, and again, I'm unsure of this whole process.
Yeah.
I just did the offices, Rexburg and Idaho Falls, to divide them up into the 2 groups, 1 and 2.
Okay.
But I could have that completely backwards.
Okay. Reason. Okay. Okay.
I guess I can always pull up the lesson again here.
Okay.
Yeah, so you would, what I'm looking at here on the in the textbook is that you would do the automatic recode for the group, which in this case would be the location, because there's 2 groups.
Okay. In mine, I just have the dentist bill and the city as options.
Mm-hmm.
So would I use the city?
Yeah, that's what I did. I brought the city in, and then I renamed it to group.
Okay. So do you just click on the variable? So you click on city and then move it over to the right.
Mm-hmm.
The variable, right?
Yeah, and then right under that window, there's another one that says new name.
Mm-hmm.
Then you have to type in. I think you can make it whatever name you want. You
City code or something.
What was that?
Like in the prep assignment, they just put like code after it.
Yeah, they just put group code or group or whatever you want.
And then from there, I'm sorry.
Oh, you're fine. From there, I'm just reading this off of here anyways. Click add new name.
Yeah, the new name, and then okay.
And then from there is when you go over to analyze and then
compare.
Yep. Mm-hmm.
Okay. And then from there, the test variable would be the dentist bill. And the group.
Mm-hmm.
And then the grouping variable would be the city.
Yes, exactly.
Okay, and then you just hit OK.
Then you have to define the group.
Define the group. Gotcha.
Mm-hmm.
And that's just 1 and 2.
Yeah, exactly.
Continue. And then OK.
Mm-hmm. Yep.
All right. Sweet.
So let me compare answers for the mean for Idaho Falls dentist bill. Did you get 260.06?
I'm trying to, I got an error. So I'm trying to figure out what it's I got a warning. Can you give me, oh no, you're good. No, I did something wrong. No. That's why. Okay. Sorry, bear with me for a second here.
Oh, no, you're fine.
Automatically code. And it's the independent sample t-test, right?
Yes. Uh-huh.
The test variable, it's dentist bill.
Mm-hmm.
Yeah, man. Something wrong.
Oh, no. Okay, so I'm gonna walk through it one more time. Okay.
So step 1, you just went to transform, automatic recode.
Yep.
Right.
Yeah.
Okay. You moved over. You moved over the city into the variable box.
Yep.
You named it as group code or something like that.
Right.
And then you just hit OK.
Yep. Uh-huh. And then in your data tab, the one with all the information, there should be a third column now that has group and then 1s and 2s.
Yeah.
Okay.
Yep.
Perfect.
Okay, then you go to analyze, compare means, independent sample t-test.
Uh-huh.
You then pull over the dentist bill into the test variable box.
Mm-hmm.
And then your group code one into the grouping variable box.
Yes.
And then you define the groups as 1 and 2.
Mm-hmm.
Continue. You hit OK. And then you get answers. Sweet.
Nice.
Good. I Thank you. Sorry.
Yeah, no.
Okay. Okay, so did you get 288 as your mean?
For Rexburg?
Rexburg, and then 260.
Yes.
Hypothesis.
Uh-huh.
Good.
Nice. Perfect. So what is the degrees of freedom? What are the degrees of freedom?
Okay.
Oh, okay. And so for these, we'd always look at the bottom row.
That's right.
About it.
No, the top one. 'Cause we just always assume it's the bottom one, right?
Yeah.
Okay.
You assume it's the not assumed one. So I've got 37.996. Is that what you have?
Yeah, that's what I got.
Cool. And then the standard deviation.
206.637. Is that what you got?
For the
Rexburg?
which? The Rexburg standard deviation is, I have, 206.637. Sorry. I think my mind
did.
just.
No worries.
And the test statistic. Minus 0.434. Same in both columns anyways.
So minus 0.434.
Yeah.
I got this one. The p-value, we just use the two-tailed, right?
I think this one is, in the information up above, it says that it's going to be, they're seeing if population 1 is less than population 2 mean. I think it's going to be a one-tailed test, which would make that 0.333. Is that what you have?
Yeah.
Okay.
So in this case, what is the correct decision? Do you think, like, we would fail to reject the null hypothesis? Is that what you're thinking?
Yeah, I think so, because 0.333 is greater than alpha, which is 0.10.
Yeah.
Level of significance. So I think we failed to reject it. Now, suppose that you had used the alternative hypothesis instead of, so two-tailed instead of one-tailed. What is the correct decision based on this evidence? I think it'd stay the same, right? Still greater than 1.10.
Yeah. Right.
Okay. So that would mean B?
Yeah, I think so, because we failed to reject it, so that means we have insufficient evidence. And then, yeah.
Okay. Yeah, this is a concept I'm trying to work on. Just memorizing which one's which. But,
sounds like you're doing pretty good.
well, we'll see. Day one, check.
Yeah,
right.
we'll see.
Now we have the freshman dinner file to pull up and do all that fun stuff again. It's gonna take me a minute. My SPSS, I accidentally closed it out. I'm just gonna stretch while it's working on that really quickly.
Okay. Yeah, you're good. Oh,
I went a lot quicker this time.
not good.
Okay. Have you already started pulling it up or anything?
My SPSS is still loading too.
Oh, gotcha.
I just got
Right. Transform. Automatic recode. One represent the number of times California to Utah. You know what the point of renaming the variable is?
Yeah, I don't know actually.
Because, I mean, it seems like, I mean, maybe it's for a tab where there's a lot of information, like the class survey one. I feel like it should give you the, oh, wait, no, never mind. I know what it does. So it puts a 1 and a 2 to the, in this example, Colorado and Utah. So that the computer can compute those instead of names.
Oh, gotcha.
I think that's what it does.
Okay, because it can't use names in
Yeah.
mathematical equations.
Exactamundo.
Yeah. So in the independent sample t-test part, did you choose the freshman as the test variable, and then the group code, would that be the grouping variable?
Yeah.
Okay, just wanted to make sure I was doing that.
Yeah, I think so.
Right. Or at least that we're both doing it the same way.
Exactly.
All right. I at least got answers this time.
Sweet.
Good sign.
And just to make sure, did you have 15.2 and then 16.6667 for your means?
No, I didn't.
Oh.
I did something wrong, I think.
What were your means?
Like 7.
Well, it could have been me though. Let me redo that. Okay, so I've got 2 improperly matched.
I guess we'll see. I'm redoing mine just to make sure. I've been having some struggles with this.
Yeah, I got the same as I did before.
That's a good sign.
True, true.
Good sign for you, bad sign for me. I spent like 3 hours on this today. You'd think I would like understand it better.
Some of these things are just difficult to understand.
All right, so for the automatic recode, make sure I'm not messing it up. So would the freshman be the variable? Make sure.
It would be the state.
The state. Oh, okay.
Yeah. So the variable is pretty much the one with options and the recorded information. So freshman, but state, okay. There's two different groups, Colorado and Utah.
Okay, and the states changed. So.
Exactly.
Okay, that's where I went wrong.
And those are the ones that need numbers in the data plot that we have.
Okay. All right. That looks better.
Well, I'm just looking at the program here. Looks like Utah students cook a lot more for themselves than Colorado.
Right. Because
not a coincidence.
Okay. So in the independent sample t-test, the freshman would be the test variable.
Yep.
Okay. And then the state code would be the grouping variable.
Yeah.
Then you define groups 1 and 2. Okay. Okay. 15.2 and 16.667.
Yeah, that's what I have.
All right.
Perfect. Sorry about that. All right, perfect. So, what is the appropriate alternative hypothesis for this?
Okay.
All right, let's see.
So, in my mind, it would be B.
I think you're right, because it just says a different number of times instead of more or less.
Yeah.
Okay, that makes sense. And then we've got all the data from this thing right here.
So what is the test statistic round to 3 decimal places?
So I have mine as 0.845.
Great. That's what I got as well.
Cool. And we're looking for the p-value here, and this is a two-tailed test, so we can leave it as is.
So 0.410, right?
Yep, that's what I have.
Oops.
It's 0.05 is the level of significance.
So fail to reject, right?
Yeah, I think so.
Okay. The 95% confidence interval is, it just does that by default, right?
Yeah, it's in the little table on the far right side. And this one, I believe, is correct.
Okay.
Instead of having to do what we did for that one lesson.
Okay. Awesome.
So we've got to determine the margin of error, which I have yet to be able to do on any of these group quizzes or homework assignments. Apparently.
You're good. So margin of error for the 95% confidence interval. Okay, well, in my homework, I've been able to get it.
Really?
I have, but I think
You know what you've been doing?
I think I was just using the old formula from lesson 9, I think. And it was working out for me. I don't know what I was doing differently.
Hmm.
Let me pull that up.
That's probably my problem, because in the videos each week, when we talk about confidence intervals, he gives the equation for them, and he always different for each lesson.
Really?
And there's always one section of it, the latter section, that is marked as margin of error at the end.
Yeah.
And that's what I keep on doing, but I always get that wrong, so it's probably what you're doing. Either that or I'm just terrible at math.
I don't know. I think you're pretty good. Was there a margin of error section in this homework or in this?
Yeah, I had one under confidence intervals, that section.
Okay.
The second half of the equation, which was the critical point, or in this case t, square root of s1 squared divided by n1 squared plus s2 squared plus, or divided by n2.
Okay.
Now,
Who knows if that's.
Yeah.
We could try it. 'Cause
I am down to try yours or whatever else you have up your sleeve. I'm fine with whatever.
I didn't watch the video for this one.
Okay.
Shame on me. So I didn't see that.
Sometimes that's all I do, because I guess I learn better through the videos than the text. And then I just go back and look at the SPSS part of the textbook.
Okay, just to make sure you know how to do it.
Yeah. But I need to start. Here.
Oh, that's good. Okay, I'm gonna pull up the old formula and see if I can see
Okay. Sounds good.
if that works for me.
I'm gonna try setting up the one that we had.
Okay, that's perfect.
Let's see.
We'll see.
Thank you.
So what was your formula again? One that,
Was the critical value, or represented by t in this case, t times the square root of, and then the rest of this is in the square root, s1 squared divided by n1, which is the sample standard deviation of the first sample divided by the sample size of the first sample. And that plus s2 squared divided by n2.
okay. So well, that is completely different from the other formula. So
Yeah, it is. And it's I just don't know what it is.
wow, that's interesting.
Almost worked it out.
Okay.
The t is 1.960 for 95%, right?
Actually, I had negative 0.867 minus 0.867 on the thing we just worked out, right?
For like the t in that equation. Remember how there's a chart of 97%?
Oh, yeah, gotcha.
Yeah, it's 95% is at 1.960.
Yeah, yep.
Well, with this formula, I got 5.909, but that hasn't been working out for me past.
We can try it. I'm just about done with calculating the other one, but I don't know. It's totally different from the one you got from the video.
Yeah. Oh, hold on a second. Someone's here.
Yeah, you're good.
Hey, how are y'all? She's at the library.
Oh, really?
Yeah.
I know, she told me that she might be going to her.
Oh.
I told her that I'd bring her company. So will you tell her that I talked about
I
it?
will. I'm sure she'll appreciate it.
Right, and then tell her that I thought about not bringing her because it's not the
You know, looks don't even matter.
It's true, it's been gone. Minutes.
Well, thanks again. I appreciate it. I'll let you know.
See you around.
See ya. Wife's visiting teacher brought her a cupcake.
Oh, really?
Yeah, and it's very tempting.
Hey, she'd never know.
That's right. She won't even like it anyways.
We probably have something better in Russia anyway, right?
Yeah, exactly.
Okay. You know what? Maybe we should just try yours, see if it works this time.
Okay, we can give it a shot. That's
Yeah.
for sure.
I mean, if that came from the video, then
Yeah.
probably.
So, this doesn't say how many percentage points, so I just kept 3 again. And it was 5.909.
That sounds good. All right. Okay, lower bound. We got negative 5.140.
I actually have negative 5.137.
Okay, that's actually what I had. Never mind. I was just rounding weird.
Oh, okay, gotcha. I was a little nervous here. It's like, oh no.
Something went wrong again. Oh. Okay.
Upper bound 2.204.
Yeah.
Okay. So since we're guessing with my marginal error, which is probably not right, I can go ahead and submit mine.
Okay, go for it. Thank you.
Yeah. Submit. Oh, okay. We missed one, and yet again, the margin of error was that
Oh man,
94.74%.
yeah, that's pretty good.
It is. I'm so frustrated. I don't know why I can't get the margin of error.
Well, let me see if it says anything in the individual prep. I don't remember seeing anything about it.
I'm going to Google how to find the margin of error for a 95% confidence interval.
Okay, perfect. Actually, so never mind. I thought that was something.
Got my hopes up.
It says that if there is a 0 in the confidence interval, then we conclude there is no significant difference between the two populations.
Oh, right.
So would that mean there would be no margin of error? Actually, that's probably not what it means.
Yeah, I don't know about that. Maybe.
I don't know. I found a margin of error calculator,
Hey.
but it only takes one sample size. It doesn't take.
Do you think that to find the margin of error, you have to include the first part of the confidence intervals equation, which is just case population standard sample mean of sample 1 minus the sample mean 2 plus or minus the rest of what we already had?
You could try it. Yeah, I don't know.
Let's see. I guess that would give us a different answer, though. It would be plus or minus. So it gives us two different answers.
Okay. I don't know.
And mention margin of error in the text for this reading. I'm gonna try calling my wife, see if she remembers.
Okay.
And to tell her that she has cooked before.
Good idea. I'll just keep seeing if I can find something here.
Okay, sounds good. The one and only downfall of my wife. She doesn't answer her phone very well. Perfect in every other way.
That's it. Well, if that's it, then that's pretty minuscule, right?
Yeah, I guess so. It'd just be nice to know.
You give me your phone number, I'll call her and be like, hey, Thomas wants to talk to you.
There you go. There you go. What was that?
Yeah, I'm not seeing anything. Wonder. I'll go ask my wife if she knows anything.
Okay.
Pretty smart.
Oh, she's in a group meeting.
Oh, your wife is?
Yeah.
Okay. Okay, I'll be right back. Well, that was a good noise.
Yeah, she just said that she might be able to help in 15 minutes.
Okay.
So we could always. What, did your wife know anything?
She said she used to.
Gotcha. So we could always break and then submit the quiz later if you wanted to.
Yeah, no, that'd be great. We can just talk with each other if we find anything out.
Okay. Sounds good.
Sound good? Alrighty. Well, we'll talk to you later, Thomas.
All right. You too. See ya.
Yeah.